All right, hello again, Jeff Scott of Blackhawk Technical College. We've been going through the first 17 chapters of the iOS 9 App Development Essentials text that we're using for the 152-153 Mobile Web Development iOS class for the spring 2016 semester at Blackhawk Technical College. I'm up to Chapter 13, working with array and dictionary collections in Swift. What I'm going to do is to save the project that I was working on for that bank account, and now I'm just going to take it and I'm going to I want to close the project, and I want to go back again once I do that and try to figure out the fastest way to do it. I'm going to just open up again my playground. Alright, while that's opening, and it is, let's go back and look on here. So again, there are two things that are discussed in this chapter: arrays and dictionary collections. Both of them work with objects. So the idea behind this chapter is to just discuss some of the fundamentals of arrays, some of the fundamentals of dictionaries. We're going to look at each, but I'm going to look at both of them under the guise of using a playground file in order to be able to do that. All right. Now, I don't want to read to you, but so what I want to do is I want to highlight this code, or this stuff in the book here that's in blue, and let you look at it while I talk. All right. And what I want to say is, back before there was Swift, there was Objective-C. Objective-C has actually been around for, I don't know, it's been probably at least 25 years. All right. And it was the language that when Steve Jobs left Apple, before he came back, but when he left Apple and he went in and founded Next, he ended up using Objective-C for all of the work he did. The guy, in many ways, I think at least, was very visionary and realized that there was a lot of good in that language. And one of the reasons that Apple ended up buying Next and taking Jobs back, in my opinion, was Objective-C and the strength of its language. All right, so I'm taking a short story and making it too long. When you worked with Objective-C and you created an array, there were actually two different kinds of arrays that you could create. You could create what was called an immutable array, which meant that once you set up the array, you could not change the values that were, you couldn't make it any bigger. You could actually change the values that were in it. All right. But, and actually, I think that's what I said right the first time was correct. The contents of an immutable array cannot be changed after it's been initialized. But when you've got a mutable array, you can change it. All right. So what does this have to do with anything? Well, if you remember, the two words that we've been using a lot in this class have been let and var. Let implies that something is non-changeable, i.e. it's immutable. Var implies that it is changeable, i.e. whereas let is immutable, var is mutable. All right? So this next section is a little bit hard, possibly the first time you look at it, on 13.2 there. The author says an array is a data type designed specifically to hold multiple values in a single ordered collection. All right, so when you look at this, here's an example of creating an array. And notice again that when you do this, all right, that you'll see a few things that are different. All right, you're used to in C or in Java when you create an array using curly braces. Here we use brackets, not angle brackets, just brackets. This creates an array that's mutable, this tree array, and this creates the same array but makes it immutable. So as mentioned right underneath the line that I have there in blue, it says the Swift compiler uses type inference to decide that the array contents are of type string. But if we wanted to, we could also do something like this, or have the same thing with a let. All right. Arrays do not have to have values assigned at creation time, which is a little different than it is, whoops, in at least some programming languages. I don't know what happened there, but so as it says, you can create an empty array by saying, and here's an example, var price array equal float paren paren. Another thing that you can do, as mentioned there, and this is, I'm up to the top of page 100, is it says that you can allow an array to be initialized to a certain size with each element predefined to hold something. All right, and they show you an example of that here. Again, I can't go down too much further because then it'll pop off the page, but right there. So as mentioned, when compiled and executed, this code will create a new 10-element array where each element is initialized with a string that reads my string. Well, let's try that one. All right, let's actually go in and look at some code here. So I'm going to copy that to the clipboard. I'm going to go back into here, and I want to do a file, new, and I want a new playground page. This was my tupled stuff that I worked on previously. All right. So this is called Untitled. Well, we're going to have to change that in a bit, but that's fine. In fact, here, let's go into here where it says Untitled page. And I want to change that to Array and Dictionary examples. And I don't want to change that one because I guess I already had one that was called Untitled page. How about label example here? And this is the page here, Untitled page 2. All right, so I want to change this to Array and Dictionary examples. Okay, as always, let's remove everything from here and let's import UI kit. Now I'm going to paste in that line of code we had before. There it is. All right, well, you can see at least syntactically it worked just fine. Okay, so according to this, we should have in here 10 strings, and each string should say, all right, each string should say my string. Well, let's check out a couple things first. All right, such as let's print name array dot count, and that should print, hopefully it'll print 10. And of course, it's giving me an error message because I didn't put the name array.count inside of parentheses. Now, hopefully, it's going to print out a 10 for me. And there it is, 10. And it's right here also as 10. Okay. Now, you can do some neat things with arrays. They give an example of this on page 100, where they first say var first array equals, and they're going to put some colors in here, red, green, blue. Totally fine. And a second array, which is going to be equal to a couple more colors that they put in indigo and violet. All right, nothing big there, but now they come in and create a third array, and they say it's equal to first array plus second array, which is kind of cool because now in our third array, what we actually have in there is we've got a new array that's got 5 elements. All right, we can always go back and we can open this stuff up if we want to. So there it is. There's our first array. So we can go and look at all that stuff if it helps. There's our second array. And there's our combined array. Okay? Which is kind of cool stuff when you think about it. It's pretty powerful that you're able to do something like that. All right? Since I used var on each one of these, I can change the value of any of these if or as I need to. So I can come down here and as an example, I can key in here third array sub, and that third array had in it, let's see, it's got red in there for its first color. So let's say sub 1. All right. Well, the first thing I can do if I want to is I can print that, and it should say green. Print. And you see green there, and you see green down here. But if I decide I want to, I can also come in and change its value. So I can say third array sub 1 equals orange. All right. And now I should have gone in there and I should have changed those values in third array should now be red, orange, blue, indigo, and violet. All right. I can append elements onto an array. All right, so I can say third array plus equals, what haven't we used yet? Black. Or I can also say third array dot append, and I can add a color that way, white. All right. Now, let's see if we say for color in third array, print color. All right, notice, well, what we have in here. Well, there's a couple things it doesn't like, but we'll look at that in a minute. But before we do, notice we've got red, orange, blue. Okay, so what doesn't it like here? Plus equal cannot be applied to operands of type string and string. It's because what I have to do is I have to put this inside of brackets itself. And that should make my error go away. And it did. But now look when I print this out. All right, I've got orange because I replaced that one there. Blue, indigo, violet, black, and white. So everything that I've added is now in there. So that for in loop is a way of iterating my way through an array if I want to do that. All right. So far, what we've looked at is just a very simple example here. All right. So what I'm going to do is I'm going to come back up to the top here. Try to get back up to the top. And I want to take all this stuff that I've created thus far and I want to comment it out. All right, it'll give me an error message down near the bottom. I don't care. All right. And I'm just going to give myself some white space here. There we go. All right. So far, all we looked at was an array that held the same types of values. But as mentioned on the top of page 102, they say let mixed array. And they say here type any object. What that means is now I'm able to combine elements of different data types. So I can say a string, and I can put a number in here, an integer, And I can put a float in here. And I should even be able to hopefully put a Boolean in there. All right. And really, I don't even need to say any object in here. You can see that it all looks okay. So if I wanted to iterate my way through here, all right, if I wanted to iterate my way through here like we just said, for object in mixed array, print object. All right, there they are, a string 432 3.1459, and notice it shows true as being 1. If I change that to false, this should really change to 0. And you see that it does. All right, but the same thing would work if I left the any object out of there, because using int-type inference, the system would be able to figure out what it is. So notice it still works. All right, I've shown you a couple of the things that are in here. We've looked at the count, for example. And now we just looked at arrays of type any object. Now, they do mention halfway down on page 102 here, the author says, the use of any object should be used with care, since the use of any object masks from Swift the true type of the elements in the array. In other words, you're possibly opening yourself up for problems. All right. What if I had a mixed array, but I put all numbers in it, and then later I decide to put in a non-numeric value, and then I decide that somewhere in my in here I want to go and I want to do some numeric calculation, but one of the values in my array, one of these subscript or one of the elements, is not a number. That can cause things to happen that you probably wouldn't want to have happen. All right. That was a quick introduction to arrays, so let's switch gears, and there's a couple more pages left in the chapter, so let's talk for a minute or two about dictionaries. All right. Dictionaries basically allow data to be stored in the form of key-value pairs. They're similar to arrays, with the exception that each item stored in a dictionary has associated with it a unique key. So whereas a regular array is number referenced or number subscripted, what you have with a dictionary rather, is something that is key subscripted. Currently, right now within Swift, you can use strings, ints, doubles, and bools as keys, and that's it. So the author mentions here and gives an example, and I'm going to type in the same one that he has. He's got var. He calls it book. I'll call it book dictionary. Equal, and then he puts here all right, and he's got 4 or 5 of these. I'll tell you what, I'll just put a couple of them in here. Get back to that. So he's got more examples in there than I do. I just kept it very, very simplistic here. All right. And he also mentions that if you don't want to do it that way, the other way that this could have been written, and let's just grab all the code and paste it back in here, and we'll just call this book dictionary 2. All right. is he said if we wanted to, we could have also written this, instead of you showing it like this, all right, where we said it's equal, we could have said here, and let me move this down, this stuff down to its own line. So we could have come in here and said colon string string equals, and that would have worked also. All right. Now, you don't have to do it the second way, because the first way uses, again, type inference to show exactly how that works. All right. You can also come in and create an empty dictionary, much the same way that you create an empty array. So if we wanted an empty dictionary, we could say var, let's just call it what it is, empty dictionary, and we can set that equal to int string. So what that says in here is the values are going to be strings. All right, the values are going to be strings, and what it's going to hold, and I've got that in wrong, so that should be there, bang, bang. All right, the keys are going to be integers, and the values are going to be strings. You can see it just shows colon, colon in there, showing that right now there's nothing in there. And just so you see this, there's my values. Okay, just so you saw that they were indeed in there. There's a count property that you can use with this, just the same way that we used the count property previously. All right, so I can come in here and I can say, for example, down here, print book dictionary dot count. It should come back and say 2, because there are 2 elements in there, and you can see that it does. All right, we can go back in and we can change values by either just replacing what's in there. So in other words, if I wanted to, I could come in and say book dictionary, and if I wanted to change the value, so I can say here, for example, 100-432112 equals, I don't know, A Christmas Carol. All right. Now I've changed the value that's in there. Okay. Similarly, I can also do it if I wanted. Let's change it back now. So we can say book dictionary. We can say dot update value. And let's change it back. So we'll say wind in the willows for key, and then we've got to put the key back in there. All right, so either one of those would work if I wanted to do some kind of an update. If I want to remove a value that's in there, I can do it in 2 ways. I can either say, let's work with book dictionary 2 here. So I can say book dictionary 2, and I can give it the key, which for let's grab the second one, 200-532-874, and I can take that key and I can set it equal to nil. All right, or I can say book dictionary 2 dot remove value for key, and let's use the other one here. So the other one is 100-432112. All right. So I can do that either way. As with arrays, you can iterate your way through this stuff using a for in loop. So let's do this. For, they say book ID, title, in book dictionary, instead of book ID, even though this isn't an ISBN, let's call it book ISBN. Okay, even though that's really not an ISBN. Print book ISBN I don't know if it'll take a \T here or not, but we'll check. So there they are. Okay, and I can also check it right there. But it says it's in there twice, so it is. Okay. Now, if I go through and do the second one, it should be empty because I've removed everything from there. So I'm going to put this back in, but I'm going to change this to Book Dictionary 2. And you notice the first one printed out, that's from Book Dictionary right here. All right. So let's change this so we're sure. So this will say Book Dictionary ISBN, and this will say Book Dictionary 2 ISBN. And you'll notice that one doesn't print out at all because we have removed up here by setting the key to nil in the first instance and using a remove value for key in the second instance. All right. That's pretty much it for a primer or a beginning to dictionaries. When I come back next, we're going to go over Chapter 14, which is Understanding Error Handling in Swift 2. So I will be back with that presentation shortly.